So good afternoon everyone. Hello everyone. Today we are going to see about the topic on universal testing machine and its applications. And its types. So the overview of UTMs are why they matters and how they support engineering and manufacturing and in research purpose, which are industrial oriented. This presentation covers the components that are used in the universal testing machine and their operations, by which principles they are working, and the types, and what are the typical tests they were conducted using the universal testing machines, and the advanced application in industries which they are using. So let's dive into our topic. So what is an universal testing machine? UTM. UTM is a laboratory instrument that applies controlled tension and compression, or maybe other forces to the material which we are going to be doing our experiments, like tension we are adding or the compression we are adding on the experimented specimen to get the required data like mechanical properties of tension, stiffness, elongation, modulus of elasticity, like that. And the universal testing machines, let us see the image of the universal testing machine. So this machine, we are going to conduct this experiment. Okay, now that it is used for the quality control, if some of the mechanical properties we need to modify, by which the universal testing machine comes here. It is used to discover the qualities which we need to change, and for research purposes which need to be implemented for the materials that we can be tested using this machine. Okay, what are the key components that are used in the UTM? So let us see the image here, that fixed crosshead. It is then a fixed state, that tension specimen by which then tension is going to be applied on the specimen that we are going to be used to examine. And here is the screw that is used to move the movable head cross, by which the tension we are going to apply, that is used to move this. And that here then fixed crosshead, by which then one side is fixed and by the other side which is going to be given the load. So here are the gears which is used to support to move the screw, and the motor which is used to give the driving force that is used for the to make this material work. So the local cell which is used for the precise force measurement, by which we are going to apply the force, how much we are going to apply the force, that is calculated by the load cell, and then activator that applies the force on the material, and the control system, that softwares that test the profiles and records the data. Let us see the data that are used and then given by the tests. So here are then some of the tests that are conducted in the industries, by which the results are visible on your screen. So yes, next slide. So how an UTM works, the principal operations that are happens in the UTM. UTM applies an controlled force. UTM applies an controlled force on the specimen while measuring the elongation, and results in the plotted load displacement stress strain curve. We are getting the stress strain curve by the UTM, and from these curves we derive the yield stress, ultimate tensile strength, and Young's modulus, elongation at the break, and energy absorption. So UTM applies a controlled force to the specimen, and measuring the load and the elongation, how much load we are applying on the specimen and how much it elongates. That results in the load displacement, or maybe stress strain curve. By this curve we are deriving the yield stress, ultimate strength, and the Young's modulus, elongation, and etc. So the setup, install the specimen in the grip and attach extensometer if needed. So let us watch the diagram, that here we need to fix our specimen which we need to examine, and we need to add extensometer if we need it. So next, apply load. We need to apply the load on the test to conduct the test on the experimenting specimen. So next we need to record the readings, we need to collect the data using the software, we need to create a curve using that the software deals with that. We have then a load cell and then displacement center. By the load cell we can calculate how much we produce then a load on the material, and displacement sensors that collects the data of how much then elongation happens. Next we need to extract the mechanical properties that are generated by the software, that the collected data, and generate the reports for our decisions. So next, so types of UTM. Generally we have 4 types of UTMs. One is mechanical UTM, another is hydraulic UTMs, and the other few UTMs are there, single column UTM and a dual column UTM. Though the electromechanical UTM is uses motors, leads, screw and ball screws. There is a precise control of speed, ideal for low to medium force range, and it is a higher resolution displacement measurement. It has a higher, the resolution is also high, the displacement measurement can be also high. So hydraulic, this second one is a hydraulic type of UTM. It uses then fluid power for high force capacity. It uses then fluid power for high force capacity. It is very excellent for very large loads in compression states, responsible but less precise at very low loads compared with the electrochemical systems, which is more used for the large loads and comparatively very low when applied then a load which is very low. So next, so types of UTMs, we are seeing then electrochemical and servo-hydraulic. So electrochemical UTMs, so precise, they are cleaner and low maintenance, which is ideal for tensile, fatigue, and so let us see the fatigue and the small sample in the upcoming slides. It is very ideal for tensile and fatigue and small sample testings. So next, servo-hydraulic UTMs, they are high force, fast dynamic control. They have more dynamic control, which is more preferred for impact and high load compressions and high frequency fatigue tests, which are usually used for high frequency fatigue tests. So the how we select which type of UTM we need to do our testing is depends on the this consideration, like the force range, how much force we need, and how much speed, and the control, and the test type, which type of material we are going to, we are going to test the material, like for impact test or then a high force test. Likewise the impact we are going to give us based on the UTMs we are selecting. So the next, so common applications of tensile testing is tensile testing. The common application of UTM is tensile testing. The tensile testing, it is used to stretch a specimen until failure. If we are applying then so if we give them a specimen and then fixed, if we are fixed our specimen here and we apply the tension, which is make it elongate through this, and then we can widely, it is we can measure the tensile strength, yield strength, Young's modulus, and the elongation, how much it elongates. Likewise if we stretch a specimen till failure, we can measure these properties, which is widely used for metals, polymers, composites, and fibers, etc. So next, other common applications are compression, flexures, and shear testing. So compression, we are going to compress the material, which are most used in the concrete, ceramics, foams, and components under crushing loads. We are generally giving a crushing loads which we are compressed on a specimen, and the more used materials are ceramics, concretes, metals. Next one is then flexure. The other common application is flexure. A flexure is that the ability of the material to resist the deformation under failure. So basically 3 to 4 point bending tests assess stiffness and breaking length of beams, composed and coatings. So next one is then shear. Shear is an destructive material test that measures the material's resistance to a force acting parallel to the plane, which causes it to slide over. So fixture selections and alignments are critical to avoid suspicious results. So this evaluates the bond strength between the strength between the bond and the adhesive performance and the interlaminar shears in the composites using specialized fixtures. So next is then beyond the basics, advanced UTM applications. So fatigue testing. What is fatigue testing is that we apply the cyclic load on a material to predict its life under this repetitive load. So if we apply a load on the material cyclic, so we can know that how a material behaves and we can predict the life under these loads. So fracture toughness. If we apply the in the UTM, how crack propagates and how fracture mechanics are working under the material in the UTM can be tested. So the other advanced applications are the environmental testing. So environmental testing that tests the temperature, humidity and corrosive environment to stimulate service conditions. So next one is the impact test using servo hydraulic system to stimulate the crash or blast load. We can given great impact on the material surface and we can measure the impacts how much it gains. So custom fixtures for components such as fasteners, welds and assembles can be also then applications of the UTMs. UTMs are integrated with the strain gauge acoustic emissions to expand the diagnostic capability. So there are the strain gauges and the acoustic emissions. So this sensor helps in the diagnostic capability to expand. We get great more results. So conclusion. So what we have been seen from the starting, let's see then the conclude. So what is an universal tension machine, a testing machine and its types. So next one is the key components. What are the components? As you can see, these are the components which are leads to the testing of the materials. So next one, how we need to set up and how to apply the load. Then we need to record this load that the software creates the curves. And next one is then analyze the mechanical properties and we can get great use it for our research purposes. So next one is the types of UTMs. We have seen about the mechanical, hydraulic UTMs and there are a few more UTMs like single column UTMs and dual column UTMs. So next one is then what we can considerations we need to maintain to get which UTMs we need. So next one is then what are the applications like tensile strengthening, which we stretch the material specimen to the failure, by which we measure the tensile strength, yield strength, Young's modulus and elongation etc. in the materials like